In Unit 8, we're going to study rational functions. We're going to start back in Chapter 2.5 and look at direct variation. Notice that the direct variation equation is y equals a of x. There's a direct variation between x and y. A is called the constant of variation. The graph of a direct variation has a constant slope, and the intercept is always at 0. So we're going to look here at the point -3, -9, and we're going to graph a direct variation, which means that it's going to go right through the origin. And will look just like that. We're going to figure out what the equation is for that. So we'll start out with slope. And we can plug in our numbers. We can call this x1, y1. The other point that we know of for sure is the origin. So the origin is at 0. Don't forget to plug in your y first. So our slope turns out to be 9/3, otherwise known as 3. So our slope is 3, and it goes through the origin. So the equation of this direct variation is 3x. Notice that the y-intercept is 0. That is true for all direct variation equations. So we like to write the equation onto our graph. We're going to look at Hooke's law, that the distance d a spring stretches varies directly. There's that word we're going to be talking about, with the force F that applies to it. Suppose a string stretches 15 inches when a force of 9 pounds is applied. Up here they stated that the distance varies directly, equals k, with the F. So the distance it stretches is 15. We don't know what this constant value is at 9 pounds. So when we divide by the 9, we can now figure out 3 goes into that 5 times, 3 goes into that 3 times. So our equation is d equals 5/3 F. Now when we come down to predict the distance that a spring will stretch when the force is applied is 6 pounds, what's the distance if there's 6 pounds on the end of the spring? How far will the spring stretch? Looks like it's going to stretch 10 inches. On page 2, this is very important, because the direct variation equation is y equals a of x. That's kind of like mx without any y-intercept. Then we can divide by x, and you can see that a equals y divided by x. That's another way to identify direct variation. Divide your values and get a constant. So when we look at this example, the dimensions of 5 rectangles, each with an area of 24 feet, are given in this chart. Show whether the length and the width show direct variation. Is this a direct variation? When you plot it out, will it go through 0, 0? There's another way to think about that. So we're going to take our y divided by our x, y divided by x, and does it equal a constant? And it's pretty clear here that 24 divided by 1 equals 24, but 12 divided by 2 equals 6. 24 and 6 are not the same. So this is not showing direct variation. This relation does not show direct variation. In fact, if you look at the numbers, you'll notice that if you multiply the two numbers, there's where the constant lies. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. This is going to be your constant value. When you multiply, that's called something different. That's not direct variation. That's actually going to become inverse variation for our next lesson.